So the equation for a quadratic in the standard form, or sometimes referred to as the intercept form, and we'll see why that is in just a moment, it's y equals ax squared plus bx plus c. For example, if you just put in some different numbers for a, b, and c, you're going to get a different equation each time. So if we have a look at this one, let's say it's y equals x squared plus 4x minus 21. And let's say we're asked to actually sketch this on a graph. So there's a few things that we need to get. The first thing that we need to get is our y-intercept. Now our y-intercept, that is just when x is equal to 0. Okay, and if we put into our equation, everywhere that we see an x, if we put a 0 in, we'll get what our y value is. We'll get our y-intercept. So y is 0 squared plus 4 lots of 0 minus 21. And well, if you crunch the numbers there, you just get 0 and 0, so you end up with minus 21. So our y-intercept coordinate is 0, negative 21. In fact, for the standard form, or the intercept form, our y-intercept is always looking at us right in the face. It's just this number on the end here. Okay, and that's why we call it sometimes the intercept form. It's just our plus c value there will always be our y-intercept. The next thing that we might want to look for is our x-intercepts. So our x-intercepts, or sometimes referred to as our roots or our solutions. Okay, and for this equation, y equals x squared plus 4x minus 21. Our x-intercepts, they always happen when y is equal to 0. So for the y-intercept, it was when x is 0. And for our x-intercepts, or our roots, or our solutions, it's when y is 0. So instead of a y here, let's plug in a 0. And well, in fact, I'm actually just going to write this the other way around. So I'm just going to flip this over, and I'm going to put equals 0 on this side. Okay, just for the ease of our working out. So I've not changed the equation at all there. Well, how could I solve this equation? This is something that we've been doing for a while now. We can factorize this. We look for two numbers that multiply to give us minus 21 and add to give us positive 4. So x, so it'll be plus 7 and minus 3. And from our null factor theorem, we can see that x has to be negative 7 or x is to be positive 3. So our x-intercepts would be at negative 7, 0 or 3, 0. Okay, and another way that you could solve this, for this one it was actually okay because we were able to factorize it quite comfortably. But for some messier ones that we might get, we might look at those in a few examples time, we can use what we call the quadratic formula. Now the quadratic formula says that x-intercepts are at negative b plus or minus the square root of b squared minus 4ac divided by 2a. Now that might look quite scary, but it's okay. We'll have a look into it. So remember over here, we've got our a, b, and c values. So for this equation, our a value is just going to be our 1, our b value is our positive 4, and our c value is our minus 21. So let's just pop those in over here so we don't forget. So a is 1, b is 4, and c is minus 21. Now all that we have to do is put those numbers into this equation. And again, it might look scary, but it's just some number crunching. So let's come over here and let's just pop those numbers in. So x is to be negative b, so that's going to be negative 4, plus or minus the square root of 4 squared, because it's b squared, so that's 16, minus 4 times 1 times minus 21. So that's going to be take away negative 84 there. And you can check that by just popping those numbers in, okay? All divided by 2 lots of 1, which is just 2. And well, if we simplify this down a bit, we get negative 4 plus or minus the square root of, so 16 plus 84, so that becomes 100 over 2. So we know that this is negative 4 plus or minus 10 over 2 because the square root of 100 is just 10. So there's two solutions here. We could have negative 4 plus 10 divided by 2, or we could have negative 4 minus 10 divided by 2. And well, negative 4 plus 10 being 6 divided by 2 is 3. Negative 4 minus 10 being minus 14 divided by 2 gives us minus 7. And they're the roots that we found over here by factorizing. So sometimes it's much easier to factorize. Sometimes if you can't see the factorization too easily, the quadratic formula will always work. It's a little bit more working out, but really it's just some number crunching, so it's not too bad. Now what we have to find is our line of symmetry. Now our line of symmetry, if I just come down here, that's our equation there. So our line of symmetry, and I'll abbreviate that to be LOS, meaning line of symmetry. That is when x is equal to negative b divided by 2a. That's a handy one to just remember. In fact, it's actually kind of hidden in our quadratic formula a little bit. So if you come over to the right-hand side of the screen, it's this negative b over 2a part. And if you kind of want to think about what's going on there, if you think about the symmetry of a quadratic shape, like a parabola, then it's directly symmetrical, which means wherever my roots are, whether it's here and here, the line of symmetry has to be exactly halfway between the two roots. There's no other way for this thing to be symmetrical. So my line of symmetry is exactly halfway between the two roots, okay? And that's where that negative b over 2a part is coming in, because it's kind of saying, okay, that's our middle point, plus or minus an amount to get to our roots. So this is our line of symmetry here, and the equation's kind of saying our root would be that far that way, or it would be the same distance that way. It's okay if you got a little bit lost there. It's as long as you can remember that the line of symmetry is just negative b over 2a. So if we look at our equation, which again is just at the top of the screen there, and negative b, well, that'll be negative b is 4 divided by 2 lots of 1 is 2, so at negative 2. So when x is minus 2, I have a line of symmetry. And finally, what I need to find now is my turning point. Now my turning point will lie directly on my line of symmetry. Again, if you look at a parabola shape, which is what we've got over here, our turning point will lie directly on our line of symmetry. So if we just pop in x is minus 2 into our equation, then that's going to tell us the y coordinate for our turning point. So if we come over here, everywhere we see an x, we're going to put in minus 2. So minus 2 squared plus 4 lots of minus 2 minus 21. And if we crunch these numbers down a little bit, we get 4 minus 8 minus 21, so we get negative 25. Now what we have to do is just sketch this thing. So we've done all the hard work. If I just erase our little graph here so that I've got a bit of room to work with, we've done the hard yards. Now we've just got to pop those coordinates onto a Cartesian plane and plot what this graph might look like. And I'm just going to give myself a little bit more room on this y-axis because we're going to need it, and you'll see why in just a moment. So where is our y-intercept? Well, we worked that out over here to be at 0 minus 21. So that's going to be just down here, about there, right? And then our x-intercept, we worked out to be at minus 7 and 3. So minus 7 might be over here, and 3 might be just there. This isn't to scale, right? It's just a sketch. If you had some graph paper, it'd be a little bit more accurate. And then our line of symmetry was at minus 2. So if I just pop that in, so x is minus 2 is our line of symmetry. So maybe that just comes down here like that. And our turning point is at minus 25. And well, if the y coordinate is minus 25, then it's going to be negative 2 for our line of symmetry, minus 25. That's going to be the coordinate for our turning point. And if we pop that in, that's going to be just down here somewhere a bit below the y-intercept. And then if we just connect the dots, again, this isn't to scale, it might be a little bit off, but it's sort of good enough, right, for a dodgy drawing with no graph paper. Our quadratic or our parabola will look something like that. That's pretty much it for the standard form or the intercept form. What we're going to look at now is we'll do a few more examples, and all that really changes is the way in which we calculate our x-intercepts here. And we're going to look at that now. So let's have a look at another example. So it might be y equals 2x squared plus 3x minus 8. And let's say we're asked to sketch this on a graph. Well, first of all, again, let's find our y-intercept. Remember, that is just when x is equal to 0, and we could put zeros into here for x, but we'll very quickly see that we're just left with our minus 8, which is out on the end here. So we get 0, minus 8. The next thing that we'll look to do is find our x-intercepts. X-intercepts. And remember, these are sometimes referred to as the roots or the solutions. And this is when y is equal to 0. So I take my 2x squared plus 3x minus 8, and instead of being equal to y, well, y is now 0. So we put it equal to 0. And now we have to try and solve this. Now, this isn't as easy as just factorizing. This is a little bit more complex. So the first thing I'd probably do here is divide everything through by that 2 out the front. This 2 out the front is quite nasty, right? So let's get rid of that. We end up with x squared plus 3 over 2x minus 4 is equal to 0. Now, rather than looking for two numbers that multiply to minus 4 and add to 3 over 2, which is almost impossible to do in our heads, we can now do what we call completing the square. So remember, for completing the square, we take our b value here, our 3 over 2, we divide it by 2, so we now get 3 over 4, and we square it. And this is what we're now going to kind of manipulate into this equation. So we get our x squared plus 3 over 2x, and I now add in my 3 over 4 squared, and I do that because this part here now is going to factorize quite nicely. And then I have my minus 4, which doesn't go anywhere, but I can't just add that 3 over 4 squared, so I have to subtract that 3 over 4 squared to keep everything fair and balanced. Now this part here that I've got in the brackets, that's just going to simplify down quite nicely to become x plus 3 over 4 squared. And then I can move all of this other junk here over to the other side of my equation, and I get 4 plus 3 over 4 squared. Now we've done the hard work. We've just got to do some sort of nitty-gritty algebra and solve this equation. So if I simplify this right-hand side a little bit, so x plus 3 over 4 squared, we won't change that, but let's simplify this to be 4 plus, and then 3 over 4 squared, that's going to be 9 over 16. And for ease, I can change this 4 to be 64 over 16. And then I can rewrite all of that to be 73 over 16 because I've got a common denominator there. So let's change all of that to be 73 over 16. Okay, now I can take the square root of both sides. I get my x plus 3/4 is equal to plus or minus the square root of 73 over 16. In fact, I can rewrite this square root of 73 over 16 as the square root of 73 divided by the square root of 16, which is just the square root of 73 divided by 4. So x plus 3/4 is equal to plus or minus the square root of 73 over 4. And if I move this 3/4 over to the other side, I end up with x, which I've now isolated to be negative 3 over 4, plus or minus the square root of 73 over 4. And I can put that finally all over one common denominator, and I get a really nice answer. That's a 3, by the way. I get a really nice answer in this standard form. Okay, if you were to pop this into a calculator, you would get two solutions pop out. So you would get negative 2.89 as one of them. So that would be your first root or solution, and your other x-intercept would be at 1.39, 0. Okay, so negative 3 plus root 73 over 4 and negative 3 minus root 73 over 4, you will get these two answers here. Now, that was quite tough, right? The completing of the square. Look, there's plenty of room to make mistakes. Another way that we could do it is again just using our quadratic formula. Remember, that is x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. And if we take a look at our equation here, our a value is 2, our b value is 3, and our c value is minus 8. And now if we pop that into this equation and we do a little bit of number crunching, a bit of mental arithmetic, we can get our two solutions that way. So negative b, that's going to be minus 3 plus or minus the square root b squared, which is 9, minus 4 times 2 is 8, times minus 8 is negative 64, all divided by 2 times 2, which is just 4. And we can start to see this come together to be very similar to what we worked out completing the square. 9 plus 64 is 73, all divided by 4. And that is exactly what we saw down here when we completed the square. So we get the same answer either way. Now, so we found our two x-intercepts. Remember, what's left to do now is find our line of symmetry and our turning point. Now, the line of symmetry, the complexity of that doesn't change by any stretch. It's just x is negative b over 2a. Now, remember, if you can't remember that, it's actually hidden over here in your quadratic formula. And negative b is just minus 3 divided by 2 lots of 2, which is 4. And we actually could see that happen here. So we've already worked that out. So our line of symmetry is just x is negative 3 over 4. Finally, for the turning point, we put our x is negative 3 over 4 into this equation. Now, this has the potential to get a little bit messy with a minus 3 over 4, but again, it's just some mental arithmetic. We can do it. So 2 lots of negative 3 over 4, all squared, plus 3 lots of negative 3 over 4, minus 8. Now, look, it's going to get a little bit nasty, but it's just sort of, mental arithmetic work. It's nothing too complex, but that doesn't mean that it's easy. So what do we get here? We get 3 over 4 squared is 9 over 16, multiplied by 2 is 18 over 16. Here we get minus 9 over 4, minus 8. Now, instead of 9 over 4, let's write that as 36 over 16. And now we can take care of this part to be negative 18 over 16. And now we've just got to subtract 8. Well, 16 lots of 8, we can calculate that. So we get 48 and 12. So we end up with 128. So I could rewrite this like that. And minus 18, subtract another 128. I end up at negative 146 divided by 16. Okay, we could start to simplify that down a little bit. Let's divide both by 2. So we end up with negative 73 over 8. Okay, and that actually works out to be negative 9.125. Okay, so look, it gets a little bit messy, but the process doesn't change, and that's what's really important. So our turning point is at our negative 3/4, so negative 0.75, negative 9.125. Okay, look, that was quite tough. What's important is the process doesn't change. Our line of symmetry, just negative b over 2a. Our turning point, we just put that value into our equation. Our y-intercept is looking at us straight on the page, but our way that we solve for the x-intercepts, we might have to use a few different types of skills that we've already learned. So completing the square, factorizing, or if you get stuck, we just use the quadratic formula. Finally, for the fun bit, if we want to sketch this, let's see how we go. So our y-intercept is at 0, minus 8. So we can put that down like that. What else do we need? Our x-intercepts, which are here and here. So almost negative 3 might be about there. And 1.5 might be about there like that. And then what else do we need? We need our line of symmetry, which is at negative 3/4. So it's this one here. So that might just be down there like that. And our turning point, which is on that line of symmetry, down at negative 9 and a little bit. So our graph will look, if we sketch it roughly, something like this. Again, if you had some graph paper and a little bit more scale to work with, you'd get something that looks much more accurate, but that's essentially the crux of it. Let's take a look at a couple more examples where we use, again, another technique to solve for our x-intercepts or our roots or our solutions. So let's come down here. So let's go for y equals 6x squared plus x minus 2. Okay. So let's go for y equals negative 6x squared minus x plus 2. So again, we're asked to graph this. First of all, we get our y-intercept. Now, once again, we could put zeros in for x because our y-intercept is when x is 0. But again, we soon see that it's just this plus 2 that's left. So our y-intercept is at 0, 2. The next thing to do, and again, this is the part that just changes what technique we use to find the x-intercept, or our roots, or our solutions. So this is when y is equal to 0. So we've now got our negative 6x squared, take x plus 2, has to be equal to 0. Look, really don't like this negative out the front here. And because we're solving for when this is equal to 0, we're not simply just factorising. We can divide everything through by minus 1. So we get 6x squared plus x minus 2, and then 0 divided by minus 1, that's just 0. So we're now solving a problem which looks far nicer because we don't have that negative out the front. Here, a technique that we could use here would be slide and divide, okay? And there's many other sort of ways that we can do it, whichever way you've learned, but we use slide and divide. So remember, that's where we drag our 6 across to here, and we multiply, so we get a minus 12 now. And then we factorise this, and well, that's just going to be x plus 4 and x minus 3. Then we divide through by what we dragged over, so we divide through by 6, and we end up simplifying these down to be 2/3 and 1/2. And then we can bring them up the top here. So we bring our 3 out the front and our 2 out the front. So we've actually just factorised this guy here. Now, if you wanted to, we could have just stopped here because we've got them in 2 brackets and we can solve for when each bracket is equal to 0. Or we could have done it here. So we can see here that x would be negative 2/3, or here x would be 1/2. And you could solve these. You'll end up with the exact same answer. So negative 2/3 is 1 and 1/2 is another root. So we've got our 2 roots there. So slide and divide was probably the best way to go on that one. Once again, we could use the quadratic formula. So we will, because I want to prove to you that it does work every time. Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So in this case, we have our b value here. Our a value is minus 6, our b value is minus 1, and our c value is 2. So let's plug those in. X is 1 plus or minus the square root of, well, b squared is just 1. So 1 minus 4 times minus 6 is minus 24, times by 2 is minus 48. All over 2 lots of minus 6 is minus 12. Okay, let's keep going here. So x is 1 plus or minus the square root of 49 over negative 12. So x is equal to 1 plus or minus 7 over minus 12. And if we did 1 plus 7, we end up with 8 over 12 with our negative because of the minus 12. Or if we did 1 minus 7, we end up with our minus 6 divided by minus 12, which is just 1/2. So there's our half that pops out. And then negative 8 over 12, I can simplify that down to be negative 4 over 6, which is negative 2 over 3, which is exactly what we see here as well. So quadratic formula does work. Finally, our line of symmetry. So back over to what our equation looks like. Our line of symmetry, that doesn't change. It's just when x is negative b divided by 2a. So negative b, negative minus 1. So divided by 2 lots of minus 6 is just minus 12. So we end up with 3 negatives here. So we end up with 1 negative in total, minus 1/12. And our turning point, I'll just use TP for turning point. We put in this x value back into our equation here. And yes, look, it's going to get a little bit messy, but we can do it. So y is equal to negative 6 multiplied by our minus 1 over 12 squared. So anywhere we see an x, we're putting in our minus 1 over 12 plus 2. Okay, let's come down here and let's crunch some numbers. So we get 6 over 144 plus a 12th plus 2. Sorry, this will be minus 6 over 144. My apologies. I can rewrite this 1 over 12 as 12 out of 144. So minus 6 plus 12 over 144 is 6 out of 144, and then I have to add 2 on the end. Now 6 out of 144, I can simplify that down to be 3 over, so for half 144 I get 72. We can keep going because 72 is divisible by 3, so I can do 1 over, what do I get there, 24. And well, 2 I can rewrite as 48 over 24. So my final answer is 49 out of 24. And as a decimal, I know that this gets quite messy, but as a decimal, that would just be 2.04. But in reality, life isn't so pretty when we deal with these problems in real life applications, and we do often end up with these decimal numbers popping out. So we get 2.04 as our turning point. So it's going to be negative 1/12, 2.04. So let's sketch this thing. We'll come down here. So this is the fun part. Our y-intercept we found to be at 0,2. So that's going to be here, let's say. Our x-intercepts, or our roots, or our solutions are here. So at positive 1/2 and minus 2/3. So about there, let's say. And then our line of symmetry is at minus 1/12, so that's really close to this y-axis. Probably not even done that close enough, right? And then our turning point is just above our y-intercept. It's almost right on it at 2.04 there. And if we connect these dots, we end up with a quadratic that has a sad face and does something like that. I know I've not gone through all the points exactly, but again, if you had some graph paper, it would be far more accurate. So we've looked at a few different examples for graphing these quadratic equations in the standard form, and the thing that changes most is just the technique that we use to solve for the x-intercept, or our roots, or our solutions. We've looked at just a straightforward factorization. We've completed the square, we've used slide and divide, we've used the quadratic formula multiple times, so we've ticked a lot of boxes there. Look, yes, some of the arithmetic and the algebra can get a little bit nitty-gritty, right, with all of the fractions and things like that. I encourage you to try and simplify all of your fractions down as much as you can and leave that in the standard form, and then look to convert to a decimal only when it comes to graphing these things. Some questions will be harder than others in terms of the arithmetic that you have to do, but the actual process will be very similar across any kind of question.